Welcome everyone to Geometry Section 8.1, the Pythagorean Theorem. This is a really kind of important topic here in geometry with right triangles. Let's go ahead and show you why. Here's the Pythagorean Theorem. We have a triangle and it's got to be given that it is a right triangle, meaning it has a 90-degree angle. And the 90-degree angle is between the sides of A and B for reference. Now, if we have that right triangle ABC, then we know the following. We know that, let me get my color change going on here. We know that A squared plus B squared equals C squared. Now, I'm not going to get into the proof of why this works in this video, but if you guys want me to make a video on why it works, just let me know. Now, because this is commutative property, we can just change this around. So we can also have B squared plus A squared equals C squared. Okay, so let's go ahead and write that. A squared equals C squared. All right, so that is the Pythagorean Theorem. Now, with that in mind, okay, we can figure out any of these sides, any third side, if we're given two. So if we're given A and B, we can find C by doing A squared plus B squared equals C squared and then solving for C. But you can also solve for the legs of the triangle if you're given the hypotenuse. So if you're given C and B, then you use that to figure out the C squared, and then you subtract from B squared to get A squared. And let me show you just real quick, just because I think it's important, what I mean by that. So let's say we have this, and we're given values for C squared and B squared, or sorry, C and B. What we want to do is we'd want to subtract B squared from both sides so that we have A squared by itself. So then you'd have A squared equals C squared minus B squared. And that's how you would solve for the other missing side if it's not the two legs given. And then, of course, what you do to solve for A is you take the square root when you're done, okay? So that's important. You're going to have to know squares and square roots for this topic. Now, what is a Pythagorean triple? Well, a Pythagorean triple is anytime we have three integers in a row that create a Pythagorean theorem relationship. So in this case, 3 squared plus 4 squared, does it equal 5 squared? Well, 3 squared is 9. 4 squared is 16. Does that equal 25? Yes, it does. 9 plus 16 equals 25. Now, notice how this doesn't work for every, like most people assume that if it's 3, 4, 5, then 4, 5, 6 also works. Not so. Let's take a look. I'm going to do a color change here. Go over to the new palette. All right, here we go. So let's try 4 squared plus 5 squared. Does it equal 6 squared? Most people assume it does, and that's not true. We have 16 plus 25. Does that equal 36? No, it does not. This equals 41, and that's not equal to 36. So it doesn't always work. Okay, many times it does not. Most of the time it does not. So the Pythagorean triples are 4 cases, and there's actually more than that, but these are the 4 main ones. 4 cases where it does work. We already know 3, 4, 5. Okay, so let's go ahead and write 3, 4, 5 down. We have 3, 4, 5. Now, what does this mean? This means that 5 is the hypotenuse. What was our color for hypotenuse? Like a purple color? Okay, great. So this is our hypotenuse, the 5, the longest side. And then these two would be the legs. So that would be leg 1, and it doesn't matter the number, and this would be leg 2. And these are all right triangles, just as a reminder. Other combinations, we could have 5, 12, 13, where 13 would be the hypotenuse. So a leg of 5, a leg of 12, and the hypotenuse of 13. That's another combination. Another one is 7, 24, 25. Oops, my little pencil's having trouble. 24, 25. Okay, that's another combination. And the last one is 8, 15, 17, and again, where the biggest side was the hypotenuse. Okay, so maybe I should write that down. So this is the hypotenuse, this is the hypotenuse. You guessed it, 25 is the hypotenuse, and then 17 is the hypotenuse. Now, with these relationships, and based on what we know of similar triangles, we know that we can multiply all these triangles by the same scale factor and create more triangles that are also Pythagorean triples, okay? For example, we could have 6, 8, 10. What did I do there? I did 3 times 2. I did 4 times 2, and I did 5 times 2. We could also have, I'm going to change colors real fast. I'm not going to do this with everyone. We could have 15, I multiplied by 5, 20, 25. That's another Pythagorean triple. Those are both Pythagorean triples because they're multiples of the original family. Okay, usually you call these like the families, the original families of Pythagorean triples. So this is a family, the 3, 4, 5 family. And you can just use what you know of multiples to come up with more Pythagorean triples. Okay, so let's go on to number 2. We could have another Pythagorean triple of, let's multiply by 4. So we could have 20, 48, and then what is that, 52? Okay, we could have 70. Whoops. We could have 70, we could have 240, and we could have 250. That could be one. Or we could have, I don't know, we can multiply by 3. So we could have 24, 45, and what is that? That's 34, 51. I think that's 51. 17 times 3. Yep, okay. So those are all examples. Again, this was times 3. This one was times 10. It doesn't matter, okay? As long as you multiply each one of the original triples by the same thing in that family. Okay, because this is a family. I'm going to copy and paste this, actually. Copy. This is a family. This is a family. The original family. And this is a family, okay? The original family. And you can just multiply them to get more Pythagorean triples. Okay, converse of Pythagorean theorem. This is simply stating that if you know that the triangle has a relationship where a squared plus b squared equals c squared, then ABC is a right triangle. Is a right triangle. Okay, so it's the converse. It's the opposite. It's going backwards. Really important to go backwards in mathematics and geometry specifically. Now, Pythagorean obtuse theorem. Now, what happens if there's a little bit inequality in here now? Okay, so there's an inequality, meaning c squared is bigger than this relationship. Okay, so if it's bigger than, and I gotta go back to my original colors. If it's bigger than a squared plus b squared, okay, so if that hypotenuse is bigger than a squared plus b squared, then ABC is obtuse. Okay, so it is obtuse. It's an obtuse triangle, meaning it has an angle that's bigger than 90 degrees. For an example, remember that 3, 4, 5 was Pythagorean triple? That's a right triangle. Okay, because 3 squared plus 4 squared equals 5 squared. 3, 4, 6 would be obtuse because 36 is bigger than the sum of 3 squared plus 4 squared. Okay, that's why this one is obtuse. And if that's obtuse, that's the definition of obtuse, then the Pythagorean acute theorem, this one's really acute, plus b squared, okay, then ABC is acute. Okay, by the same token, we know that, let's go to another Pythagorean triple. 5, 12, 13, we know that is right because 5 squared plus 12 squared equals 13 squared. So 5, 12, 13 is right. Then we know 5, 12, and we can just say, we'll call it 12.2. Okay, that's obtuse. Psych, it's acute. Okay. So it's less than 13. C squared is less than the sum of those two added together. So 5 squared plus 12 squared is going to be bigger than 12.2 squared, so it's acute. Okay, so now let's do some examples. A triangle has sides of 6, 11, and 14. Is it acute, obtuse, or right? So we simply just need to take the two smaller ones. Okay, so obviously this is the smaller one. This is a smaller one. And we are going to add those together and see how it compares to the bigger one squared. So 6 squared plus 11 squared, and then we're going to put a mystery box here, and then compare it to 14 squared. So 36 plus 121, that gives me 157. Okay, 14 squared, my mystery box. This is 196 on the right. And obviously it is not equal. It is greater than. Now this represents c squared, so this is obtuse. Okay, because the c squared is bigger than the sum of a squared and b squared. That would be your c, okay? All right, find the value of x. This is applying the Pythagorean theorem. And we have radicals. This is going to be a fun one. Okay, now what I would do here is if you are still struggling with this concept, I'd really make sure that you identify your hypotenuses first. So let's consider two triangles, one triangle at a time. We have this one right here, this blue one. Okay, and we know it's a right triangle because there's a right angle given there. And we're going to call this C because it's the hypotenuse. We're going to call this A, and we're going to call our missing side B. Okay, so we're going to start with that because this one, this green triangle, the one with X in it, notice how it has two variables? That's no good. If we have two variables, that means we can't solve anything. So we have to solve for this missing B first. We have a right triangle with two given information. We have the hypotenuse, which is 4 radical 5, and we have the leg, which is 4. So we can solve for that one. So let's go ahead and start with the blue triangle. We have C squared, that's that, squared, equals A squared, 4 squared, plus B squared. And that was A squared plus B squared equals C squared as a reference. So we have 16 plus B squared. We're going to leave B squared alone for now. And now when we square, okay, we have to square the 4 and we have to square the square root of 5. So that gives us 16 times 5. Square root of 5 squared equals 5, just as a reference. So now we do 16 times 5. That gives us a rewind 80. So we have 80 equals B squared plus 16. Sorry for my B, it looks a little ugly. Minus 16 minus 16, that gives us 64. B squared equals 64. So we know that B equals 8. Okay, so B equals 8. We're almost done because now we have two sides for our green triangles. Let me go over here to the green triangle. Okay, green side. This time we're missing C. Let's label our sides. This is B. We already called the other one B. So let's call this our A for the green triangle. Honestly, it doesn't matter. The important thing is we keep the legs on one side. So we have 16 plus 8 squared equals C squared. Again, that's A squared plus B squared equals C squared. So now we have 16 squared. That result is 256. Plus 64, and that equals C squared. So we need to add 64 and those two, and we get 320 equals C squared. We're going to take the square root of that, and we get a decimal. Now, I think we should simplify this in radical form. If you're looking for the decimal, it's something around 17.88. Okay, but we're going to simplify this in radical form. So let's look for perfect square factors here. This is the same thing as 32 times 10. That's not that's not a perfect square factor. I bet 16 is a factor though. So let's do 320 divided by 16 and we get 20. So 16 is a factor. The reason why I like that is because I know the square root of 16. So I'm going to circle it. I'm not going to box it. I'm going to circle it. I'm going to actually put it in highlight too. Okay. And the reason why is because I know this is 4 and 4, and that's a pair. And I'm going to come back to that and circle it. And the other factor is 20. So now I'm going to break this down into its prime factors. Normally what I do is I break it down into its prime factors, 2 and 10, 2 and 5, and I'm done. Okay. Now I'm going to circle all my doubles here. I'm going to circle this double. Okay. And I'm going to box the single. You have to have a pair to leave the house. So I could rewrite this as a square root of 4 times 4 times the square root of 2 times 2 times the square root of 5. The reason why I do that, square root of 16 times square root of 4 times square root of 5. Square root of 16 equals 4 times 2 times square root of 5. That's 8 radical 5. So really this could be written as square root of 320 is the same thing as the square root of 64 times the square root of 5. That's basically what that means, okay, just as a reference. But that's what I was doing. I was looking for a number that I knew that goes in it that's a perfect square. And I essentially could have jumped steps here. Because I circled this, I could have said it's equal to the square root of 16 times the square root of 4 times the square root of 5. That's another way to do it, okay? But anyway, that is Pythagorean Theorem. Hope you guys enjoyed this video. Make sure to leave a comment if you want anything else shown. And I look forward to seeing you next time on Wes Explains Best.